All right, more log equations. So with more log equations, all that we're really doing is we're just adding on an extra feature, an extra step before we actually solve. So what we have here is two logs, and we're going to combine them using our properties. So remember, if it's subtraction, we divide. So it's x squared minus 4 over x minus 2 equals 2. So because of this subtraction, I divided. So then this is the base, this is the exponent, and it's equal to the value, which is that whole big mess right there. So then we just solve this. That was all the log part. The log part is done. So now we just solve. So why don't you take a second and see if you can solve this. And then I'll come back with the answer. Right, so this is what I got. I got 9 over 1, so I cross multiplied. And I got 9x minus 18 equals x squared minus 4. Set it equal to 0. Got x squared minus 9x plus 14. Factored, t-charted. Got my 7 and my 2. We do have to go back and check that 7 and 2. And the x squared minus 4 up here. And the x minus 2. I don't really have to plug it in and find an answer. What I have to do is I have to make sure these two things are greater than 0. So x squared minus 4 has to be greater than 0. And x minus 2 has to be greater than 0. So when I plug it in, I'm going to try the 2 first because it doesn't work. So, so it's 2 squared minus 4. Is that greater than 0? Well, no, the 0 is greater than 0. That is false. That is a reject. Okay, if I plug, so I rejected it, I don't have to check the 2 in this one, even though I can see it's also 0. But I should check 7, pretty straightforward. If I plug 7 in for x here, I get 49 minus 4, and 45 is definitely greater than 0. Also, I should try 7 here. 5 is greater than 0. Those both check. So 7 is our only answer, and 2 is rejected. So this one over here, it looks nasty, but you know, they all do. So since we're adding, we multiply. So the bases stay the same. It's x plus 3 is this base. So I'm going to be multiplying 2x plus 3 and x plus 5. So remember, it's just like fractions almost, where this stays the same and those two get multiplied. So this is the base. And that's being raised to the 2 power. And that equals 2x plus 3 and x plus 5. So please feel free, box it out, do something for both of these. Remember, this is x plus 3, x plus 3. It hurts to have to do that so much, but whatever. So then when I multiply this through, I wind up getting x squared plus 6x plus 9 here. And this one is 2x squared plus 13x plus 15. You don't believe me? Multiply it out yourself. Now solve this guy if you would, and we'll come back with some fantastic answers. Okay, so here I squared, you saw this, I did this already. So I moved the x squared, the 6x, and the 9 over by changing their signs. Combined like terms, I got this mess. Factored it, t-charted it. Okay, so this you could factor here. Sometimes you might have to quadratic formula this, maybe even completing the square if you're feeling fancy. But in this case, we were able to factor. So final thing we have to check is we have to go back up here and check everywhere there's an x. So there's an x and x plus 3, 2x plus 3, and x plus 5. So that's every place we have to check. Again, you can plug it into the whole thing and just see if it's equal like a regular check. So we have to check these 3 things for our 3 values. So this is the base. Remember, the base has to be greater than 1, and the values just simply have to be greater than 0. So when we do these, if I plug in -6, that is -9. That is false. So -6 is rejected. It's rejected on one of them. I don't have to check it again. But I do have to check the -1. So this one winds up being 1 is greater than 0. That's good. Plug in the negative 1 here again. That is 4. Oop, 4 is greater than 0. That's good. And if I plug in negative 1 there, that one checks. So negative 1 is a fine answer. See, I can have negative answers. The values and the bases just can't be negative. So these things can't be negative. X can, though. All right? Oh, sorry, these things. All right, have a great weekend.